Hi, welcome to my presentation. I'm Chaitra from MCA. Today I'm going to discuss about a concept called CPU scheduling algorithms in OS. Before going to know about CPU scheduling algorithms, let us know what is CPU scheduling and why it is important. CPU scheduling is nothing but in a multi-programming operating system, multiple processes are working in a memory at the same time. So, since there is only one CPU that is in a single processor system, the CPU must be shared among all the other processes. So, this is where actually the CPU scheduling takes place. In other words, CPU scheduling is also known as a mechanism where the operating system decides which process gets the CPU next. So, when multiple processes are ready to run, it decides which process should get the CPU at what time. Why CPU scheduling matters? Why it is important? It maximizes the CPU utilization. That is, it keeps the processor busy. That is, it keeps the CPU busy as much as possible than keeping the CPU as idle. So it maximizes the CPU utilization. It also improves system responsiveness, especially when it is important in interactive systems. It improves the system's responsiveness. It reduces the response time or waiting time. It ensures the proper allocation of resources so that no other process can wait, or it reduces that waiting time. It manages concurrency. It means when the multiple processes are running, it allows multiple programs to run so that without creating any disturbance, and it creates an kind of a parallelism where the multitasking can be done. And it increases the throughput. More processes are completed in less time. Throughput is nothing but it's in like how long it takes to execute the process. Like within a given time, how many number of processes are executed by the CPU. So here are the key concepts. Few key concepts, that is processor states and performance metrics. The processes are nothing but a program in an execution, and the states are like new, ready, running, or waiting, or a terminate state. It defines in what state the process is. And the metrics is mainly dependent on performance metrics, that is throughput and latency. As I have mentioned, throughput is nothing but the number of processes are which are executed by the CPU within a given amount of time. Especially, this throughput is used to find the efficiency of CPU. So for a long processes, for a long processes, the throughput rate might be less, whereas the shorter processes which has throughput might be high. So it mainly varies depending on the size of process. So this is how the CPU scheduling has been classified. This is the classification of scheduling. That is, it is classified into two types: preemptive and non-preemptive. Preemptive is nothing but it is one of the scheduling type where it allows the operating system to interrupt when any currently running process has been processing. During that time, it allows the operating system to interrupt and move it back to the ready queue if any higher priority process arrives. So this is how the preemptive works. Like when a process with a higher priority or a shorter arrival time, the current process is paused there and the CPU is assigned to the new processes. This is how the preemptive scheduling works. When it comes to non-preemptive scheduling, it doesn't allow any interruption of the running process. So only when the CPU is only released when the process either it completes the execution or it switches to the waiting state. For example, in case of when any process need of IO device, so the CPU is only released until it completes its execution or it switches to the waiting state. So this is how it works. This is the main difference between preemptive and non-preemptive. Under preemptive, there are several scheduling algorithms, and non-preemptive scheduling algorithms. Let's see a first algorithm, that is first come first serve. As name itself suggests that first come will be served first. So this process task is mainly on arrival order. So the process that requests the CPU first will be allocated the CPU first. So the main policy of this FCFS, that is first come first served, is easily manageable with a concept called Q, that is FIFO concept, first in first out. So it is one of the non-preemptive scheduling algorithm. The jobs are executed in the order of their arrival time. The main advantage of this first come first served concept, that is scheduling algorithm, is it is very simple and as well as easy to implement. Let's see it with an example. So here is an example of where there are three processes with its duration as well as order and arrival time. So the order looks like the P1 has the first order and P2 holds the second order and the process is 3 as third order. So for according to the order, the first come is P1, it has to be executed, and the very next is P2 process and P3 process. For the P1 process, waiting time is 0 because there is no any other process to be executed before P1, so it doesn't wait for anything. It is the first to be executed, so it has 0 waiting time. P2 has a waiting time of 24 as P1's duration, that is first time, is 24. Until P1 gets executed, P2 has to wait for P1 execution completed. So that its waiting time is 24. When it comes to P3, that is process 3's waiting time, it is 27 because P3 has to wait, its order is 3. So it has to be wait until first and second has to be completed. So P3 has to wait for P1 and P2, that is P1's duration is 24 and P2's is 3. If we add 24 plus 3, that is 27. The waiting time for P3 is 27. So in order to find the average waiting time, we are calculating each process waiting time, that is 0, 24, 27 will be added up and divided by number of process, that is 3 processes. So if we divided by that 3, we'll get an average waiting time of 17. So this is how actually the first come first served scheduling algorithm is worked. So before moving to this, let's see why the first come first served has been failed. So as we know that there is a advantage of FCFS, that is it is very simple as well as very easy to understand and easy to implement as well, but it is failed with one common thing, that is average waiting time. So in the previous example we have seen P3 process has to wait for P1 and P2 and P2 has to wait for P1. Though P2 and P3 had less duration time, it has to wait for P1 until it completes its execution. So that is how the first come first served work. P1 has 24 time of duration, so it has to P2 and P3 has to wait so long until it's completed. So average waiting time is increased. So this is why we are moving on with another scheduling algorithm, that is shortest job next. Shortest job next or shortest job first. So in this shortest job first, they have come up with that drawback, that is it requires the burst time. We'll be knowing the burst time before, and we are coming up with that drawback and solving the problem for average waiting time. So in this shortest job algorithm, it executes the shortest jobs first among all the jobs, that is among all the different process to be executed. It chooses based on the order of shortest jobs. So this is how it works. Let's see it with an example. Here is an example where we have 4 process and with its burst time. When it comes to this example, we can see the burst time column where the very shortest job is with 3, with burst time of 3. So that 3 is for process 4, P4. So that the P4 will be executed first as it has a shortest burst time of 3. Therefore, like for waiting time for that is 0. Then after P4, the very second will be executed is the very next shortest job. Except P4, we have P1, P2, P3 now. Among these three, the very shortest job is for P1, that is burst time of 6. So P1 will be executed second, and because P1 it is larger than P4, but it is shorter than P2 and P3, the other processor. So it will be executed second. Now we have P2 and P3 are remaining. Among these two, the very shortest job we have to find out, that is P3, which has burst time of 7 when compared to the burst time of P2, that is 8. So P3 will be executed third as it has a burst time of 7, which is larger than P4 as well as P1, and it is shorter than P2. So it will be executed third. And later now the remaining last executed process is P2, which has a burst time of 8. So this is largest burst time of all the other processes. No other processes are remaining, so it will be executed at the last. So each time if we see the waiting time for each processes, that first will be a 0, then for P1 it will be a 3, and again for P2, P3 it will be 9, and P2 holds 16 waiting time. So somehow we have been reduced the average waiting time compared to first come first served, where here based on the shortest jobs it has been executed. But only one thing, it has both advantages as well as disadvantages. The advantage is like it minimizes the average waiting time. As we have seen the drawback in first come first served, it has been resolved here. It become an advantage here. But the disadvantage where it fails is it difficult to know the burst time in advance itself. Before choosing this shortest job first scheduling algorithm, we have to be concentrated and known about the burst time for each processes, so that in advance knowing the burst time in advance may lead to starvation. So it is one of the disadvantages of shortest job first. So we are moving with the next scheduling algorithm, that is priority scheduling. So in this priority scheduling, each process is assigned to a priority, like the CPU is given to the process with the highest priority, like with the lowest number. So it can be preemptive or non-preemptive. So the in case of priority scheduling, it is not always known for CPU's first time. Rather, it can be internally or externally. Scheduling is done basis on the priority of process, where actually the process is highly needed or most urgent in the will be processed first. So this is how the priority scheduling works. It executes the mainly a higher priority tasks first. So let's see it with an example. So here we have an example of a table where we have a four process and with its CPU's burst time and priority. While concentrating on the priority column, where we have been allotted a priority, we are given a priority for each process, which has the higher priority, that is with a lower number ascending to the descending. So one, that is for a process 2, one has the first priority, that is process 2 will be executed first, which has the highest priority, and the very next we can see that two processes are equally prioritized, that is P1 also having a priority of 2 and P4 is also having a priority 2. So when in this scenario, when we have both P1 and P4, which is equally prioritized value, since P1 has arrived before like CPU is allotted to the P1, so the P1 will be executed. If we have a equal prioritized process, we will be looking forward which has been arrived first. So in this case, among P1 and P4, P1 will be executed first and then P4 will be executed. So in the order, it will be like P2 will be executed first, that is with the first priority, and with the second priority among P1 and P4, P1 will be executed first and P4 next, and at last the P3, that is which has the third priority, will be executed at last. So thus the order of like execution will be like P2, P1, P4 and P3. So this is how actually the priority scheduling works. It can be both preemptive priority scheduling as well as non-preemptive priority scheduling. In preemptive priority scheduling, like if the new process arrived at the ready queue, uh, which has a higher priority than the current running process, the CPU will be preempted, which means the process of current process is stopped, and the other incoming new process with a higher priority will get the chance for the CPU to be executed. So this is where the interruption is allowed in the preemptive. When it comes to non-preemptive priority scheduling, in in case of this, the algorithm, like if a new process arrives with a higher priority than the current running process, that the incoming process is put at the ready queue, and which means after execution of the current process only it will be processed. So no interruption is allowed in non-preemptive here. So this is how the priority scheduling works. So when coming to this, choosing the right algorithm on future trends, each one of it has its own advantages as well as disadvantages. So while choosing the right algorithm, it mainly depends on what actually we are going to perform. So the algorithms mainly depend on specific system goals. So it can be often used as a complex or hybrid algorithm, so that it has to be adapt dynamically to workload changes. So this is how choosing the right algorithm is most important, as we have seen like three different scheduling algorithms, that is first come first serve and shortest job first and priority scheduling. Each one of it had advantages as well as disadvantages. When it comes to first come first serve, we have seen that it is very easy to implement as well as efficient and easy to understand, but it failed with average waiting time, and it has been improvised in shortest job first, but there it lacks in starvation, and advantage was average time. So when coming to the priority scheduling, we have seen it has come up with a starvation, but has been fought with priority based, sometimes blockage or a lower prioritized process can be waited for too long. So in order to come over that, solution has been found for aging concept. So this is how we have to choose the right algorithm based on what specific system goals we are going to perform. So by this, I conclude by saying that CPU scheduling is one of the fundamental component as well as concept of any modern operating system. It is mainly responsible for selecting which process has to get use of the CPU at what at given time. So, in order to efficiently manage the execution of the multiple processes order, CPU scheduling mainly ensures the maximum CPU utilization time, and also the improved performance and also enhanced user support or user experience. We have seen different scheduling algorithms like first come first serve, shortest job first, and as well as priority scheduling. And also why CPU scheduling is needed, also we have seen, like in order to efficiently manage the CPU as well as multiple processes can share the CPU effectively. The main goal of that is to make utilization of CPU and as well as the responsive time and efficient execution. And also if I give let me give you an example, a real scenario, real life example. Let me take a scenario of a smart phones multitasking. Like I have a scenario like I'm listening to a music as well as let me take okay, I'm listening to a music as well as I'm downloading a file, and I'm chatting on a WhatsApp with my friend as well as I am on call. I'm receiving a call. So these are my scenario where multitasking I am performing. So how CPU scheduling helps in this scenario in the sense the CPU will give the short time slices to each task so that all the process can run simultaneously. So this is also one of the scheduling algorithm like round robin scheduling algorithm. And also priority scheduling also takes place here where uh, the call app. I said that I'm listening to the music, downloading a file, and I am on a call as well as I'm chatting on WhatsApp. Among all this, the call app may get higher priority over other scenarios like listening to the music or downloading file. So the first priority will go to receive a call, and the call app have higher priority, and then it goes to downloading a file rather than listening to the music and downloading something file, so that it goes the next priority, then listening to the music as well as chatting on a WhatsApp. So this is how it works. And if I give another example of OS, like how the background tasks perform, let me take a present scenario itself, like on a laptop. Okay, at present, I'm working on my laptop, like antivirus is scanning at the background, as well as I'm trying to type something in my MS Word, and also a software update is downloading. I have been given a download for software update, as well as I am recording this presentation. So among all this, in the background there are several tasks are running, that is antivirus is scanning, but I cannot type in MS Word as I am recording here the presentation. It doesn't allow there. This is the priority scheduling, and the software update is downloading in the background. So the OS schedulers, like there are three types of schedulers, CPU schedulers, that is long term schedulers, short term schedulers, and medium term schedulers. So the OS schedulers tasks so that typing cannot be done instantly, so that while heavy background tasks are running smoothly in the background without freezing the system. So this is how actually it works. Like I have mentioned, there are types of schedulers like long term, short term, and medium term. Long term schedulers will mainly decide which processes are admitted into the system for processing. They are also known as job schedulers. When it comes to short term schedulers, it decides which of are in a ready queue and in a memory processes that has to be executed next by the CPU. When it comes to the medium term scheduler, it suspends or resumes the process to control the degree of multi-programming. So based on this, the types of schedulers, mainly it works. So these are all the real life scenario, how actually the OS decides and the CPU scheduling will take place. With my scenario that I have given, which I'm working on my laptop, the OS schedulers tasks so that the background tasks are running smoothly in the background without freezing the system. There are several uh, real life scenarios, example like ATM machines it might be, or sometimes online video conferencing meet or gaming, etc. Thank you.